In the far reaches of our solar system lies Pluto, a dwarf planet that has always captivated scientists' imaginations. For decades, we believed Pluto to be a frozen, barren world with little to offer in terms of discovery. However, NASA's New Horizons mission, which passed by Pluto in 2015, dramatically altered our understanding of this mysterious object. One of the most surprising discoveries was the possibility of a hidden ocean beneath Pluto's icy surface. This was an unexpected revelation, and it has since become one of the most compelling areas of study for planetary scientists. Could there be life on Pluto? What's really going on beneath its frozen exterior? Let's dive in and explore these intriguing questions. Before New Horizons, the thought of an ocean on Pluto seemed far-fetched. Pluto is so far from the Sun that it should be a frigid wasteland, but the mission's findings revealed a complex and dynamic landscape, filled with vast nitrogen ice sheets, enormous mountains, and intriguing geological features. One of the most intriguing discoveries was the presence of water ice on Pluto's surface, particularly in its highlands. Scientists had speculated for years that Pluto might have an ocean beneath its icy shell, but the New Horizons data provided strong clues that this might be the case. In fact, this ocean could be much more than just an interesting geological feature, it could potentially harbor life. As scientists began to investigate further, they noted that Pluto's surface seemed to show signs of tectonic activity, with fractures and faults running across the planet. These features suggest that Pluto may have a subsurface ocean that could provide the necessary conditions for life to survive. While the surface temperature is incredibly cold, the possibility of warmth beneath the surface, provided by a potential radioactive heat source within Pluto's core, means that liquid water could exist beneath the frozen crust. The question then becomes, could life really exist on Pluto? According to renowned physicist Brian Cox, there is a chance. Cox believes that the heat from Pluto's interior might be sufficient to create an environment that supports organic chemistry. This could lead to the formation of simple life forms, much like the primordial conditions on early Earth. However, life on Pluto, if it exists, would most likely be very basic. Complex life, as Cox points out, is likely quite rare in the universe, and if it exists on Pluto, it would probably be no more advanced than single-celled organisms. Still, the mere possibility that life could thrive in such a harsh, cold environment is exciting. It shows that life might not be as rare as we once thought. Interestingly, while Pluto's ocean holds immense potential, it's not the only celestial body that has captured our attention in the search for extraterrestrial life. Moons like Europa, Enceladus, and Titan, orbiting Jupiter and Saturn, also have subsurface oceans, and they are considered to be more likely candidates for finding life. Europa, for instance, has been shooting water into space, and Titan is thought to have a liquid ocean beneath its surface. Still, Pluto's ocean remains a tantalizing mystery. Could it be that life is more common in our solar system than we initially believed? While it's still too early to say for certain, the possibility of life on Pluto adds to the excitement of space exploration. One of Pluto's most famous features is its heart-shaped region, known as Sputnik Planitia. This massive nitrogen iceberg, covering an area of over 1 million square miles, is located in a basin on Pluto's surface. For years, astronomers thought this region was the result of a violent collision. However, new research suggests that the alignment of Sputnik Planitia with Pluto's largest moon, Charon, might be due to a process called polar wander, where a planet shifts its axis due to geological processes. The alignment between Pluto and Charon is fascinating, and it hints at the possibility that Pluto's surface is far more active than we once believed. As Pluto shifts, nitrogen ice accumulates in Sputnik Planitia, creating a massive glacier. This, in turn, suggests that there might be an ocean beneath the icy surface, providing the necessary pressure for this process to occur. When scientists examined Pluto's surface more closely, they noticed something extraordinary. The region around Sputnik Planitia, called Ptomal Rio by Brian Cox, is home to a range of mountains made of frozen water ice, some of which rise up to 6 kilometers above the surrounding landscape. This area is also strikingly smooth, without the usual craters that cover the rest of Pluto's surface. But it gets even stranger. On closer inspection, scientists found polygonal shapes, similar to cells, carved into the ice. These formations are the result of Pluto's internal heat desperately trying to escape from beneath the glacier. This creates a lava lamp-like effect as nitrogen ice rises and falls, forming these unique structures. The discovery of these patterns, combined with the absence of craters and the unusual behavior of the ice, suggests that Pluto is far more active than previously thought. Some scientists believe this heat could be coming from radioactive materials in Pluto's core, providing the energy needed to keep the planet's internal processes going. While we can't say for certain that Pluto has an ocean, the evidence points in that direction. Data from New Horizons suggests that Pluto's surface and tectonic activity are consistent with the presence of a liquid ocean beneath the surface. If an ocean does exist, it could be a remnant of Pluto's early history, when the dwarf planet may have been much warmer than it is today. New models of Pluto's formation suggest that the ocean could have formed rapidly, perhaps as a result of a large collision with another object in the past. This impact could have cracked Pluto's icy shell, allowing a subsurface ocean to form. Over billions of years, this ocean may have remained relatively stable, creating a potential environment for life to exist. The possibility of an ocean beneath Pluto's surface changes the way we think about the outer solar system. If Pluto does indeed have a liquid ocean, it suggests that other objects in the Kuiper Belt and beyond may also have similar oceans. This could mean that the search for life in our solar system is far from over, and that we may yet discover alien life in the most unlikely of places. As scientists continue to study Pluto, the excitement surrounding its potential to harbor life only grows. While we may never find advanced creatures on this distant world, the mere possibility of life, however basic, is enough to fuel our curiosity and push the boundaries of space exploration. The question of whether Pluto can support life remains unanswered, but the evidence we have gathered so far suggests that this small, icy world might be hiding more than we ever imagined. Who knows what other secrets Pluto holds, waiting to be uncovered by future missions and discoveries.